I tried my first biochip model last autumn. It was my first try with primary cells in the biochip, and I infected it with Aspergillosis fumigatus, and it worked. I saw growing hyphae on top of intact as well as stressed and also dead cells, and even invasive hyphae towards the endothelia side. And yeah, that was a very happy moment for me. My name is Noreen Schuck, and I work as a technical assistant here at Dynamic42 in the lung-on-chip model team. I always liked cell biology very much. I find it fascinating to see cells grow. I really like cell culture techniques, and with the organ-on-chip model, Dynamic42 has a really special and complex one to work with. To be honest, I found the biochip model by accident, because back then I was applying for a master thesis which was advertising work with the fungus Aspergillus fumigatus. But when I was there, they introduced the biochip model to me, and I learned a bit about the lung-on-chip model with these two cell lines which are in contact through the porous membrane, and I was really fascinated by this cool complex 3D model, the perfusion on one side, and the lung epithelial cells were even in an air phase, and this was really cool, and I was really hoping then they would accept me as a master student so I could get to know this chip model and work with it, and they did. The most exciting project I'm working on is the big ATANA project, ATANA for antifungal therapy approaches by nanoparticle-based targeting of active substances. We are 8 great partners which are working on this project. Dynamic42 is one of them, and our role is to develop a complex infection model where we can investigate the aspergillosis and treat it with drugs which are enveloped in nanoparticles. So that's our role where I'm working on. Yeah, my work in ATANA is involving many different techniques and methods. For example, many microdilutions to determine the minimal inhibition concentration, LDH assay for cytotoxicity, Alarma Blue for cell viability, and of course the infectious aspergillosis on chip model itself is involving the permeability assay to see the damage, to investigate the damage of the barrier, and also LDH assay, and of course the fluorescent microscopy picture with the observer microscope. A recent breakthrough for me was the infectious aspergillosis on chip model itself, because after a lot of microdilutions and in vitro testing on plates, I tried my first biochip model last autumn. It was my first try with primary cells in the biochip, and I infected it with Aspergillosis fumigatus, and it worked. I saw growing hyphae on top of intact as well as stressed and also dead cells, and even invasive hyphae towards the endothelia side, and yeah, that was a very happy moment for me. So one misconception I can clarify is one which I even produced myself, because when I get asked by friends and family what am I doing, I always tell them that we are building small organs on chips. But of course this is not really correct, because we are more building the physiological situations of the specific organs in contact with the endothelial cells of the blood vessel. This would be the more correct answer than what I said.